This video demonstrates how to estimate regression functions in Excel. This is a very useful tool in the era of computers where regression functions no longer need to be estimated by hand. Technology has also been used to develop ways of collecting very large data sets. This era is also called the era of big data or analytics. Those are all referring to the same sort of thing. Most statistical software packages, or I might even say all of them, have some way to estimate regression functions. Excel is a rather primitive program. It's really built for accountants, but it can do a lot of statistical work too. And it takes a built-in command similar to the commands for F distributions or T distributions and the normal distributions. But once it's done, all of the important information that you need to do any hypothesis tests for individual slopes, those would be t-tests, the global f-test for a regression problem, or any of the other analysis steps for an ANOVA test or a regression analysis, including things like R-squared. Those are all provided by the same commands in Excel. I have a sample data set here with arbitrarily named variables. So I've got a variable called y, has values ranging from about 4 to 16.8, I think is the max. And then 3 x variables, all of different sizes. And suppose the function that we want to estimate is y being explained by, we can even type it out down here, y equals, usually they're called b's or betas. Call it b1 or b0 is an intercept. Be a little bit careful here to not think of that as b times 0. Plus b1 times the variable called x1 plus b2 times x2 plus b3 times x3. What we want to do is estimate the values of b0, b1, b2, and b3. So this would be our intercept, and then we've got 3 slopes in front of our 3x variables. Now to do this, we need to go up to the Insert tab up at the top of Excel, or at least that's the current version of Excel. Oh, no, it's not under Insert. There we go. It's under Formulas. And there's a button to the left here called Insert Function. Now if you ever don't remember the name of the command or the function that you want Excel to perform, click on that Insert Function button and it'll give you this window that has an option to type in a question or the sort of process that you're asking Excel to do. So if I type in regression here, Excel will give you a short list of commands that are related to regression. And the first one that we want here is linest. It means linear estimation or line estimation. In their description here it says it returns statistics that describe linear trends among known data points, so you have to have the data already, by fitting a linear model or a linear regression using ordinary least squares. So hit OK. And then it brings up this window here that allows us to enter the cells that includes the data that we want to use. And you can do that with this user-friendly method if you want, and you get a description here of all of the things that Excel is looking for. And with a little bit of practice, you can skip this window if you want. And you say, well, I know the command is linest, so I just type that in, open parentheses, and here are the 4 things that Excel wants, but you don't get descriptions now. Our known y variable is in this column. Don't highlight the top. Our known x's is a grid that is 3 columns wide. That's right there. For this thing called constant, just trust me that you always want to type in either 1 or true to calculate the y-intercept. And then for stats, it's offering that it will calculate extra regression statistics for you, and I see very little harm in always just asking for the extra information. So put in a 1 or a true there. Now Excel only gives us one number, and remember that what we were looking for here was an intercept and 3 slopes. And ideally we would also calculate things like sum of squares total, sum of squared regression, sum of squared errors, maybe a measure of correlation or a measure of R squared, maybe a standard error, maybe something to perform an f-test. Well, Excel can only put one number in one cell. So the solution here, you have to highlight a whole bunch of cells, and I believe it needs to be 5 tall and 4 wide. And if it's confusing as to why you would need to do that, if you've ever forgotten, a really useful skill would be to be able to use the Help menu. Now to do that, you double click on the cell where you've got this command, and if you click on linest, it will open up Excel's Help menu for that function. This is a really useful thing to be able to do for independent troubleshooting. And this Help menu gives you all sorts of interesting examples and descriptions of what this function is doing. So it tells you here what known y's mean, what known x's means, what constant and stats means. It gives you a description of all the things that it gives you in its output. And there's this little grid here. Now what this essentially means is it'll give you your first slope, your second slope, your third slope, fourth, fifth, and then the last thing it gives you is your intercept. And this grid here I already have typed down, but it's important to know that this is where you would find it. Because there are 4 things that we want estimated, that is 3 slopes and 1 intercept, that's why we need this highlighted area here to be 4 wide, to those 4 slopes and intercepts. And whenever you do this, you always need your highlighted area to be 5 columns tall. Next, this is kind of strange, highlight that 5 by 4, in this case where we have 3 x variables plus an intercept. Hit the F2 button if you're on a PC. And then this is a little strange. Hold down the Control button and Shift, and then push Enter. What this does is it tells Excel that this linest command up here is not just supposed to be applied to one singular thing or one single cell. It's actually supposed to be applied to this entire grid. If you're using an Apple, I believe what you need to do is probably hold Command and then Shift and Enter, but I really don't know that because I'm not familiar with Apples very well. My guess is, though, that the Help menu would give you everything you need. Now, in that Help menu, Excel was also telling us what all of these numbers mean, and I have that already typed out for you. When you highlight this block of x variables here, the information that Excel gives you works backwards. So this first slope is for the last variable that you've highlighted, or this last column. So this is the slope in front of x3, and in our equation down here that corresponds to b3. This is the slope in front of the variable x2, which down here we've called b2. Slope in front of the variable x1, and then this is our intercept. We have standard errors for all of those estimated values, all of those b's. This is Excel's reporting of the value r squared. It tells us that about 69% of the variation in y is explained by the x's. Standard error of the dependent variable y. The f statistic has already been calculated for you, so that's very handy. Remember that for an f-test there are 2 values for degrees of freedom, the numerator and the denominator. This reports the denominator degrees of freedom, n minus k minus 1. And if you wanted to calculate the f statistic by hand, it gives you the sum of squared regression and the sum of squared error. And that would be these values up here. So that one linest command, it's a little technical to get it set up, but it provides you a lot of information that you can use to conduct just about any analysis or tests for a regression that you would want, including t-tests for individual slopes, f-test for all slopes if you just want to report the power of the regression with an r squared. All of this output is given with one simple Excel command.